Alright, for this problem we've got two barrels, barrels A and B. They're supported with a foot truck, and so this foot truck is kind of a right angle, and we tilted that whole thing back by 30 degrees. I'm asked to determine all the forces acting on barrel B, and as we're going to see, I'm going to need to look at barrel A to figure out all of the forces acting on barrel B. So step one in equilibrium analysis is going to be to draw my free body diagrams. So I'm going to draw a diagram of both A and B. So barrel A here is at the top. I'm going to draw barrel B down here. And each one of these is going to have a weight force. And so the weight is going straight down. Top barrel, this one's A, this one's B. Top barrel is 150 pounds. Bottom barrel is 200 pounds. Alright, and then we're going to also have normal forces wherever two bodies are in contact. And so I have a contact point between A and B right here, and so that's going to be supporting barrel A. I'm going to call this one FAB. And I'm going to have a kind of contact between the wall and barrel A. Over here, I'm going to call this one FAW. Alright, looking down at barrel B, I'm going to have an equal and opposite force. So these two bodies are in contact. Newton's third law says that if I've got FAB pushing up on barrel A, it needs to be pushing down on barrel B. Same magnitude. Alright, I also have the force from the wall over here. This is going to be FB wall. And I'm going to have kind of the base of the foot truck, or the floor. And so I'm going to have a force I'm going to call FB floor. Alright, so with this, each of these two free body diagrams, I'm going to treat it like a particle. All of the forces are concurrent. They're all traveling through the center of the barrel. And so I'm going to have sum of forces in the X and sum of forces in the Y to work with. If I look at those two equations for the bottom, I have three unknowns. So I'm not going to be able to solve for three unknowns with two equations. I'm going to need to find some way to simplify this before I can solve it. Up at the top, though, I've got only two unknowns, the force from the wall and FAB. So if I look at barrel A first, I can solve for both of these values. Since it's a Newton's third law pair, FAB is pushing up this direction, down this direction. If I figure out FAB up here, I can plug it in down here. And that's what lets me solve for these other two forces down here. So I'm going to start with barrel A in this particular scenario. Alright, so barrel A, let's do sum of forces in the X. And this is the point where I'm also going to point out something else. So the X and the Y directions, usually I do horizontal and vertical, but in some cases it's beneficial to tilt the axes. And so I'm actually going to make the X direction up 30 degrees, so this is the X direction and this is the Y direction. That means that FAW is going straight in the X direction, FAB is going straight in the Y direction, but this is the one, this 150 pound force, I'm going to need to break that down into the X and Y directions. So this is actually going to be 30 degrees from the Y axis. Alright, so in the X direction, I'm going to have FAW, and I'm going to subtract off 150 times the sine of 30 degrees. That is the X component of this vector here. And sum of forces in the X is going to be equal to 0. If I do sum of forces in the Y, I have FAB is in the Y direction. and then this 150-pound force, the y component, is going to be 150 times the cosine of 30 degrees. That's going to be equal to 0. Alright, so I could solve for FAW and FAB at this point. The one I need is FAB, and I'm going to look at this bottom equation. I can very easily solve for FAB. It's simply going to be 150 times the cosine of 30, which is equal to 129.9 pounds. Alright, and I can plug that value in over here and solve for these other two forces there. So this is one of the three forces. This is a force acting on barrel B. It's one of the three forces I'm looking for. Alright, if I write out my equilibrium equations, I'm going to use the same axes for barrel B. Sum of forces in the x direction, it's going to be FBW, and then I subtract off the x component of this 200-pound force here. So minus 200 times the sine of 30. And the sum of those x components is going to be equal to 0. Alright, sum of forces in the y direction. I've got FBF down here. That's in the positive y direction. I'm going to have FAB pushing down, and I know that is 129.9 pounds. And I also have the y component of this 200-pound force, so minus 200 times the cosine of 30. And that sum is equal to 0. Alright, so pretty easy at this point. I've got one unknown in each of the two equations. If I solve for FBW, I'm going to wind up with 100 pounds for that. And if I solve for FBF, that's going to be 303.1 pounds there. And so these are the other two forces. I've got FAB, FBW, and FBF. It's the magnitude of these three forces, these three normal forces that are shown on the diagram. So with that, we've solved our problem. Thank you for watching, and I hope to see you again.